Alright, so for this part of the video, I'm going to show how I solved the management CTF challenge within the PWN category. So the first thing I did here was just read the message we got. So we've come across a management interface, but we can't get access to the server. Also, they're looking for a source or binary file of some sort, and we're told, all we're given, no source code, is the IP address and the port number where this information is. So from here, what I decided to do was use netcat to get over there. So NC, then the IP and port number. And it says, please wait, compiling interface.c. So this stood out to me on first glance because I figured that file would be of significance. And I saw we had three choices here. So naturally, I started with one and enter access code. And at this point, I knew we weren't given a password. I was like, maybe we need to find the password in the file, but that doesn't seem right. So I just tried some easy ones like password. That didn't work. I tried easy, but I assumed something like this would be a little more complex than that. So from there, I moved on to two. And I saw we had two files, so choose license agreement to display. So I first started with mcafee.txt, and so it just opens this, and this is a lot of info. And I remember I scanned through this, and I didn't see anything of use. It's just a lot of liability stuff. It's like a McAfee document, like corporate, so that's not what we're looking for. So I went back to read EULA, and I tried norton.txt, and that didn't have anything we wanted either. This area looked a little interesting, but it wound up being nothing important. So what I did from there, I remembered from our previous assignments, if we couldn't see a file, sometimes the ... command would allow us to see it. And I remember the file that we were looking for, if we go back, is compiling interface.c. That's the file we're looking for. So at this point, I just tried ... and then what do we have? Interface.c. So then from there, it opened the file, and I looked through it, nothing much here, and oh wait, we have a flag. So at this point, we're done. We got the flag that we needed, and to prove that it works, we'll put it in here. And we already solved it, so that's why it's saying that. So to actually go about fixing that vulnerability error, what we could do is, you see in this area, we check for file inputs with a dot. However, if we included an if statement in here somewhere that would check for two dots on a file input, then we could have code in there that says to stop the command from executing. That way people can't move up to directories that they're not supposed to be going to. So that should be one way to go about fixing this problem. Alright, so in this part of the video, I'm going to show you how I solved the ping wrapper CTF challenge. So to start off, what I did was I went on the CTF website and saw that I needed to download these two files. So I went ahead and did that, and I opened the pingwrapper.c, and in the description it said there's a file called flag.txt that looks interesting. So I went into pingwrapper.c, and I started looking through it, and I saw, oh yeah, I left it in flag.txt. So we're looking for something in there, and then it says encode your transmissions, and then upon seeing these strings, I found that very interesting, and it said encode, so I thought it would be worth trying to encode or decode these. So I first started with decoding, and I went to a decoding website, entered this code, clicked decode, and it said I forgot to check for $, and I forget what these symbols are called. So that led me to believe that the command that we would run would use these in some way or another. So what I decided to do next was actually run the code. So my terminal window here. To actually run it, I needed to connect to this right here, this IP, and port. So let's see. So at this point, we needed to enter an address to ping. And keeping in mind the $ and those two other symbols, I was looking and I found a command called dd that could be very useful for this type of thing. So what I did was entered this, dd equals if, or dd if equals flag.txt. And then I saw this, ping 365 CTF, I am out of here. So that looked like it would be the solution to me. So then I copied that. I went into the ping wrapper challenge, and that passed the test. So as far as developing a solution to this problem goes, one of the first things that stood out was that first string that I decoded. It said that we forgot to check for $ and parentheses. So with that said, I feel like a solution to this problem would be in the code adding $ and open and close parentheses is symbols that are not allowed. And then from there, people wouldn't be able to ping IPs or ports that they're not supposed to, i.e. they won't be able to crack this problem like I was able to. Alright, so at this point in the video, I'm going to show you guys how I solved the Find Me challenge within the Re category of the CTF challenges. So obviously the first thing I did here was click the Find Me, and we see that we need to find the password, and it's written in a weird way. So my first thought was, maybe this is the password. And then it says the flag does not follow the flag format. So for the previous CTFs challenges that I finished, they had a bracket format, but this one's going to be different. So I downloaded the Find Me file, and I will show you that on my computer. So here it is, and I don't have a lot of programs that can open this. The unarchiver doesn't, so I'm going to go to text edit and see what we have here. So upon looking at this, obviously this is encoded in some format that is not very readable to us. It's a lot of gibberish, but this is the right file we want. We just need to find a better way to look at it. So the first thing I did was Wireshark. I tried opening it in Wireshark, but I quickly realized that was not the right decision. The output wasn't any clearer, so I decided to try Ghidra because that was another tool that I had used in assignment 6 and thought, hey, that might be useful for this as well. And luckily it was. So obviously the next thing I did was open up Ghidra. So let me find that. And it's down in here. Ghidra public. And run. And it may take a while to run this, just because I'm doing a screen recording.
A few moments later.
Okay, so we'll close this. So this was from earlier. So I'll just redo what I did. So I made a new project in Ghidra, non-shared project. We'll call it Find Me because I already have another one with the actual name. So Find Me. and then we go to edit or file, import file, and then we look for our download. So the download that we had was called Find Me. So let's look for Find Me, and I already have it there. So we'll import that. Okay. And we are slowly but surely chugging along here.
A few moments later.
Alright, so now we're in the actual findme.dms file and we can look at it. So I started scrolling initially and nothing really stood out to me just yet. And I kept scrolling here. And I started to see functions. So that started to interest me. String comp. Okay, some more functions. Think undefined, start. And after seeing all these functions, I was curious where the actual password might be. So I looked in start first, I remember, and nothing really stood out in there. So I was like, okay, maybe we should look for a main method or a main function. And a faster way to do that was just going on here, looking for program text, and we can go to functions, and then just search for a function name. So we're searching, but we found it. Okay, we're at main, right here. And as you see, we have our code on the right here. So this is a lot easier to look at. So let's just look in here. So we have a variable, an offset, and some basically array buffers to take in the user input. So we have some string comparisons here, which is very promising because string comp is a widely used function with passwords. So I was looking, so it says u and then string comp is stack 36. If that says found, and then if stack 32 says me, then it's success. So that means together, if the whole input equals you found me, which that should be obvious enough that you found it, you found the password. So yes, this was our solution, literally just concatenating that. And I'll show you on the site that it works. So it was U with an O. Yep, and it's already there because I already typed it. But you'll see you already solved this. So yeah, that's how I went about solving that CTF challenge. So as far as actually fixing this vulnerability error that we have here, you know, I was easily able to figure out the password just by looking at what the string comp was comparing to. So I think they could either maybe save you found and me in variables somewhere else in the file, but that would still be easy enough to find. That would be like a minor security measure, but I think your best bet would just be putting all this code in a file that people couldn't read or open in any way. So yeah, just making it a secret file so people couldn't open it would be the best way to fix that.